Imagine sitting in a room full of radio receivers, headphones on, listening to the static of the universe. And then, one night, hearing something that doesn't sound like static at all. Something that sounds like a pattern. Something that sounds like it was made. That is exactly what happened on August 15, 1977, at the Big Ear Radio Telescope in Ohio. And what the astronomer on duty wrote in the margin of the printout, a single word, became one of the most famous annotations in the history of science. He wrote, "Wow." The WOW signal remains to this day the most compelling candidate for an extraterrestrial transmission ever detected. It was a narrow-band radio signal lasting 72 seconds, coming from the direction of the constellation Sagittarius. It had exactly the characteristics that scientists had predicted an intentional alien transmission might have. It was never detected again, despite decades of follow-up observations. We still don't know what it was. The search for extraterrestrial intelligence, SETI, has been ongoing for more than 60 years. It began in 1960, when astronomer Frank Drake pointed a radio telescope at two nearby sun-like stars and listened for signals. He heard nothing. But the idea was sound, and it has been pursued ever since, with increasingly powerful instruments and increasingly sophisticated analysis. Drake's experiment, called Project OZMA, lasted only a few months and covered a tiny fraction of the sky. But it established the principle: if intelligent life is out there and using radio technology, we might be able to hear it. That simple idea has driven one of the most sustained and ambitious scientific searches in history. The logic behind SETI is straightforward. Radio waves travel at the speed of light and can cross interstellar distances. They are easy to generate with technology that any industrial civilization would develop, and they carry information efficiently. If an intelligent civilization wanted to announce its existence to the universe, broadcasting radio waves would be a natural way to do it. And if we want to detect such a civilization, listening for radio waves is a natural place to start. The question is, which frequency to listen on? The electromagnetic spectrum is vast, and a signal could be broadcast on any of billions of possible frequencies. Early SETI researchers focused on a frequency called the waterhole, a range of frequencies between the emission lines of hydrogen and hydroxyl, which together make up water. The reasoning was that any civilization that understood chemistry would recognize this as a natural meeting place in the electromagnetic spectrum. Over the decades, SETI researchers have scanned millions of stars across a wide range of radio frequencies. They have developed algorithms to distinguish artificial signals from natural ones. They have enlisted millions of volunteers through projects like SETI at Home, which used the idle processing power of home computers to analyze radio telescope data. And they have found nothing definitive. A handful of intriguing signals like the WOW signal that were never confirmed, but no clear, unambiguous message from another civilization. Does this mean there's nobody out there? Not necessarily. The universe is vast, and we have only searched a tiny fraction of it. The number of stars we have examined in detail is a small fraction of the hundreds of billions in our galaxy. The range of frequencies we have searched is limited. The sensitivity of our instruments, while impressive, may not be sufficient to detect the kinds of signals a distant civilization might be sending. And we have been listening for only about 60 years, a cosmic eye blink. The absence of a signal is not the same as the absence of a sender. It may simply mean we haven't been listening in the right place, at the right time, on the right frequency. In recent years, the search has expanded beyond radio waves. Optical SETI looks for laser pulses, brief, intense flashes of light that might be used for interstellar communication. Lasers can carry far more information than radio waves, and can be focused into tight beams that travel enormous distances without dispersing. A civilization that has mastered laser technology might prefer it to radio for exactly these reasons. Techno signature searches look for evidence of technology in astronomical data, unusual patterns of starlight that might indicate megastructures, waste heat from advanced civilizations, or other signs of engineering on a cosmic scale. The discovery of Tabby's star, a star that dims in irregular, complex patterns that no natural explanation fully accounts for, generated enormous excitement and speculation, though the current best explanation involves clouds of dust rather than alien megastructures. But the fact that the alien megastructure hypothesis was seriously considered and investigated by professional astronomers tells you something about how the field has matured. The Breakthrough Listen initiative, funded by Russian-Israeli billionaire Yuri Milner, has brought new resources and new energy to the search. Since 2015, it has been conducting the most comprehensive SETI survey in history, using some of the world's most powerful radio telescopes to scan millions of stars across a wide range of frequencies. It has not yet found a confirmed signal, but it has generated an enormous amount of data that is still being analyzed. Breakthrough Listen has also expanded the search to include optical wavelengths and has developed new algorithms for detecting anomalous signals in large datasets. The initiative represents a new era for SETI, one with serious funding, serious instruments, and serious scientific credibility. The question of what we would do if we actually detected a signal is one that scientists and philosophers have thought about carefully. There are protocols in place for how to verify a detection, how to announce it to the world, and how to respond. The International Academy of Astronautics has a set of guidelines called the SETI Post-Detection Protocol, which recommends that any detection be verified by multiple independent observers before being announced, and that any response be coordinated internationally rather than sent unilaterally. The question of whether to respond at all is deeply controversial. Some scientists, including the late Stephen Hawking, argued that we should not, that announcing our presence to a potentially more advanced civilization could be dangerous. Others point out that our radio and television broadcasts have been spreading outward from Earth at the speed of light for over a century, meaning any civilization within 100 light-years already knows we're here. If you're captivated by this search, subscribe and stay with the series, because in the next episode, we're going to think about what contact would actually mean and how it might change everything about human civilization. The search for signals from the cosmos is, at its heart, an act of hope. It is the belief that we are not alone, that somewhere out there another mind has looked up at the stars and wondered and reached out. Whether or not we ever find that signal, the search itself is one of the most profound things our species has ever done. It is a declaration that we are curious, that we are brave enough to ask the question, and that we are willing to listen for the answer, however long it takes. What would first contact actually look like, and what would it mean for humanity? That's next. Subscribe and keep watching. This is the question that changes everything.